So at this point we've talked all about the structure of the atom. So we have a pretty good understanding of what individual atoms look like, which means we can start understanding how they connect and how they interact. So we're going to be discussing different types of chemical bonds and how we start to actually build up molecules and different chemicals and compounds. So one of the most important things to remember, that is not what I wanted. One of the most important things to remember through all of this is why atoms form bond in the first place. So atoms bond in order to become more stable. Always. If a chemical bond forms on its own, it does that because independently the atoms are what they are. When they come together and they connect, they become more stable, or their energy goes down. So usually what we're looking to do when we form compounds or molecules is to fill the valence shell of our atoms. So atoms generally want to end up with filled S and P subshells in their valence shell in order to maximize their stability. So this makes them look like noble gases in terms of their arrangement of electrons. So we talked about using the noble gases as kind of that reference point in our electron configurations. When we abbreviate an electron configuration, we reference the previous noble gas and then add stuff onto it. And part of the reason that we do that is that noble gases are very, very stable and generally non-reactive. So we're referencing something stable and we're saying it's like this stable thing, but with this extra stuff. Because atoms generally want to have the same electron arrangement as a noble gas when they can in order to maximize their stability. So how they achieve this filling of their valence shell, depends on the type of atom. So how atoms bond depends on the type of atom. So different elements tend to be involved in different types of bonds, and sometimes it depends upon what they're connected with. There are a lot of different ways of categorizing elements, but the one that's going to be most important to us is whether or not something is a metal. So if we look at the periodic table that I've got here, it can be divided up. Let's change colors. Go a little thicker. It can be divided up into metals and non-metals. So we have a sense of what it means for something to be a metal just from going about our daily life. Metals are commonly silver, shiny things. They're not all silver, but they're often hard and shiny. They conduct electricity well. And they're all kind of lumped together on the periodic table. And actually, most of our elements are metals. So there's this dividing line. It's often referred to as the staircase, that you will often see drawn in periodic tables. And it goes right here. So the elements immediately around this, let's make them green, are sort of somewhere in between. They're not metals, they're not non-metals, they're what we call metalloids or semi-metals. So everything, almost everything I should say, that touches this staircase is considered a metalloid. So the things I just highlighted in green are what are known as metalloids, or sometimes they're referred to as semi-metals. Either name is fine with me. Everything to the right of that So carbon, nitrogen, fluorine, chlorine, the whole noble gases, everything over here is our nonmetals. And then everything to the left, which you will notice is most of the periodic table, are our metals. So we have quite a lot of metals. Oops, messed that up, sorry. One exception is hydrogen. Hydrogen is not a metal. But everything else over here is. So this whole region of the periodic table is considered metals, as well as this block down here, known as the lanthanides and actinides. So most elements are metals, actually. Cool. And then again, our one little weirdo out here is hydrogen, is a non-metal. But the rest of these guys are our metals. So how something tends to bond both depends what it is and what it's bonding to. So metals bond differently to nonmetals than nonmetals bond to other nonmetals. Those are the two situations that we're going to investigate in this course. We're not really going to deal with bonding between different metals. It's unique and a little bit different and not something we need to spend much time on. We might do a little video on it, we'll see. But anyhow, for today, we're going to focus on two different types of bonding by looking at what elements we're dealing with and what they're connected to. So the first one we're going to talk about is known as ionic bonding. So in an ionic bond, what's actually happening is that electrons are completely transferred from one atom to the other. So we have a transfer of electrons. When something gains electrons, it becomes an anion, a negatively charged ion. When something loses electrons, it becomes a cation, a positively charged ion. So we're transferring electrons to form a cation and an anion. And those oppositely charged ions, opposites attract, will be attracted to one another. And that attraction is actually your bond. So this type of bonding always occurs between ions, clearly, but generally that means that it's going to be between a metal and a non-metal. So this generally occurs between a metal and a non-metal, or a metal and a metalloid. In terms of bonding, the metalloids function mostly like nonmetals. So some examples of compounds that are ionically bonded, NaCl, ordinary table salt. Sodium is a metal, chlorine is a nonmetal. Aluminum bromide. Aluminum is a metal, bromine is a nonmetal. Silver oxide. Silver is a metal. Oxygen is a nonmetal. So we can see that in each of these compounds we have one metal, one nonmetal. So that's how we can tell that ionic bonding is what's going on here, or what's likely going on here, is just by looking at what elements are involved in order to determine that. So figuring out where they are on the periodic table. Sodium is over here in the metals, aluminum was here, Silver is here, so those were all metallic. And then we had chlorine, bromine, and oxygen as our nonmetals from those three different compounds. So the other type of bonding that we're going to be working with in this unit is known as covalent bonding. So covalent bonding is when electrons are shared between two atoms. So in an ionic bond, we completely transferred the electrons. That one electron used to belong to sodium, chlorine stole it. Now chlorine has that extra electron, sodium has no ownership of it anymore. But in covalent bonding, the two atoms are actually sharing the electrons, and essentially those electrons count towards filling the valence shells of both of your atoms at once. And we'll talk a lot more about how that works in the days and weeks to come. So this generally occurs when you have just nonmetals involved or just nonmetals and metalloids. If there are no metals involved, it is almost certainly a covalent bond, but just nonmetals or nonmetals and metalloids will be covalently bonded. So some examples of compounds that are covalently bonded include water, H2O, methane is CH4, carbon dioxide, nitrogen dioxide, anything that contains just nonmetals, or again, metalloids can be included as well. They're just less common because there aren't very many of them. So these are our two main types of bonding that we're going to be dealing with going forward in this unit. Ionic and covalent, we'll kind of start talking a little bit about ionic bonding. Ionic bonding is pretty simple, and then we'll spend a lot of time talking about covalent bonding because it can be a little bit more complicated.